This lesson is over the area of triangles and parallelograms, so we're going to dive in a little bit more deeply than what we did the last lesson. The objective is students to be able to find missing parts of a shape to help them find the area. So again, that's where the biggest thing is going to be different from the other lesson. So here's the equations for the triangle and the parallelogram. We've already talked about these. Triangle is 1/2 base times height. A parallelogram is just base times height. Now, again, you don't actually need to know this next thing, but it's a little bit interesting. The reason that a triangle is 1/2 base times height and a parallelogram is just base times height is because if you take a parallelogram and cut it in half, that's what gives you a triangle. So that's why a triangle is half of the base and height, because it's just half of what a parallelogram would be. Now, the big thing, make sure you remember the altitude or the height. Sometimes they call the height the altitude, must be perpendicular to the base. So this height, perpendicular to the base. This height, perpendicular to that base. So label the base and the height of the following triangles. So this is a little bit different because there's a couple different ways you can do this. So I'm going to do all three of these first, and then I'm going to kind of show you what I'm talking about. So for number one, if I'm going to call this one the height, again, you have to make it perpendicular, so that's the height. Well, if that's perpendicular to this line, that would make that line the base. Then number two, let's see. Kind of have to try to, it's a little bit, sometimes it's really easy to do a perpendicular line. Sometimes you have to think about it a little bit, because if you just did this, well, that's not 90 degrees. So you have to think about it a little bit. So I would say this one could be here, 90 degrees, so that's my height. This length then is my base. And this one, if with this one, if I were you, I would call this my height. And this is kind of strange because it's outside of your triangle. But as long as it's perpendicular to your base, that's fine. So that's still your height. Then your base would just be this length. So sometimes it is going to be outside of your triangle, and that goes the same for a parallelogram as well. So that's one way to do it. But the interesting thing is, as long as you draw a line that's perpendicular to one of the sides, that can be the height and the base. So for instance, if I took this line, or this would be, so like, maybe we should do this one. So this one, if I drew this one straight down, there we go. So that would be 90 degrees right here. So that could be your height. If you did that, then this would be your base, this little length from here to here. So that would be another way to do it. That's, again, your height and your base. So you can kind of choose what your height and your base can be. For number two, personally, the way I would have done this one is this is a right triangle. So I would have just called this side the height, which means this side is the base. With this one, if you didn't want to do it outside the triangle, you could have done it this way. That's kind of upside down, but that'd be your height, which means this would be your base. So your base and your height kind of depends on how you draw up your triangles. Sometimes it's pretty obvious, but make sure you remember, no matter how you do it, you still get the same answer as long as you're consistent, where the heights have to be perpendicular to your base. If you had this one over here, and you called this one your height, but then you called this your base, you're not going to get the right answer. So your base always has to be perpendicular to the height. So now we got some practice problems. Number four, the height is outside of your parallelogram. So the height is 3.5. The base is 2. So the area is base times height, which is 2 times 3.5. So the area for that is 7. Again, technically centimeters squared. Now, this 4.6 is just this slanted side. If you're finding the perimeter, you would use that, but they don't ask for the perimeter. They just ask for the area. Same thing with this 4.5. We don't really use that in this one because all we need is the height and the base. So that's your height, your base. So that is base times height is 5 times 4, 20 inches squared. Now, number 6, this is one of the things that we didn't really do an example of this in the last lesson, but like I said earlier, this is a right triangle. Well, if it's a right triangle, this is the height. I mean, it's still one of the legs of the triangle, but that's fine. It's perpendicular to this. So this is your height. This is your base. Anytime you have a right triangle, you can do it that way. So triangles is 1/2 base times height. And again, if I were you, I personally would make that 0.5 times base times height because that's how I type in my calculator. So that would be 0.5 times 12 times 5. And again, just type that straight in your calculator. 0.5 times 12 times 5 is 30. There's no label. There's no inches or feet or meters, so you can just leave it 30, I guess. And this one, 1/2, the base is 9. The height is 8. So again, 0.5 times 8 times 9 is 36. And that's inches, so again, technically inches squared. I'm not going to be that nitpicky with that. So these are some you-do problems. This is where I would encourage you to pause it, do these on your own, and then hit play and make sure you check your answers. But I'm going to go through these a little bit more quickly. We have our base and our height. So the area is 1/2, 2 times 4.7. Should be 4.7. And again, technically yards squared. And we have our base and our height, since this is a 90-degree angle. So that is 1/2, 8 times 6 is 24. Sorry. Technically, inches squared. I'm trying to do that for this lesson. Make sure I label things. And parallelograms, again, they try to throw you off a little bit by giving you some of these extra sides you don't necessarily need. Again, technically, if you knew what the height was over here, then you could use that 5.8 for the base, but we're not going to worry about it for this. So that is 6 times 5, which is 30. And this one is 4 times 1.5. I think is 6, yeah, it's 6. So the next ones are going to be what the hardest part of this lesson is, and you're not going to have all the information, but you can find the information. So if you look at this, we have the height here, we have the base here. Well, the base they break up into 7 and 3, so I know the whole base is 10, so that's nice, but we don't know the height at all, so we're going to have to find the height. So the easiest way to do it is we have since this is perpendicular, it gives us 2 right triangles. We have this one on the right, this one on the left. It doesn't matter which one of those 2 you use. Since it's a right triangle, you can use Pythagorean theorem to find the other side. Technically, you could also use trigonometry if they gave you some angles, but I don't think we're getting into that. Certainly not this lesson, maybe a little bit later or maybe next chapter, but for right now, we're not going to worry about trigonometry because they give us angles. So if you want to use the red triangle, you can. The problem is I don't know what this side is, and I don't know what this side is. So we have 2 variables. We can't solve for 2 variables. So if we look over at the green triangle, the one on the right-hand side, then we know 5, we know 3. The only thing we don't know is this side, and so we can solve for that since we only have 1 variable. Just keep in mind that your 5 is your longest side. That's your hypotenuse. So we get a squared plus b squared equals c squared. Your a is 3 squared plus, we don't know what b is. And again, you can switch those around. That's 5 squared. So that's 9 plus b squared is equal to 25. Subtract 9. B squared is equal to 25 minus 9 is 16. And again, they're not done yet. It's squared, so you have to take the square root of both sides to cancel. You end up getting b is equal to 4. So that height is 4. So don't quit now, because that's where a lot of people do. That's where they stop. Don't forget, we're looking for the area. So we have the height now is 4. We said the base was 7 and 3, so it's 10. So the area is 1/2. 10 times 4, which should be 20. Again, there is no inches or meters, so you just leave it as 20. So same thing as this parallelogram. They don't give us the height, but they do give us the information for this right triangle. So again, you can call this B, A, B, or C, whatever, or I should say A or B. This one has to be C. That's your hypotenuse. So we have 8 squared plus b squared is equal to 17 squared. And I maybe should specify, this b is not the same b as our base. It's just I'm using a Pythagorean theorem. If you want to put something else so it doesn't confuse you, maybe I should have made it a. Thought about that on the last one. So maybe I'll call this A. So we have 8 squared plus A squared. Anyway, so that's 64 plus A squared is equal to 17 squared is 289. Subtract 64 from both sides. If you need to, make sure you're rounding to 2 decimal places. So now I have to take the square root. And again, if you need to, round to 2 decimal places for this part, but I don't think this one is. So that one's 15. So that is my height. And the base is 21. So we have the base is 21 times the height is 15, and that's the area. 21 times 15, 315 square feet. So go ahead and do these on your own. This one, we look at this right triangle. And again, do these on, I pause this and do them on your own, and then I hit play to check your answers. So we end up with 7 squared plus h squared is equal to 9 squared. Sorry, it's equal to. So that's 49 plus h squared is equal to 81. Subtract 49. You're getting h squared is equal to 32. Then when you take the square root of both sides, you end up getting h is equal to 2.66. Sorry, 5.66. If you're using the yellow calculators, the square root of 32 may give you something that's like 4 root 2. Again, all you have to do is hit that button right above the equal sign or right above the enter button that looks like this. It's a white button. Those little arrows are blue. That changed it into a decimal. So again, if you ever get a decimal, that's fine. Just round to 2 decimal places for me, and now we can find the area. The area is 1/2. The base is, and now remember, the base isn't just 7, it's the whole thing. So 7 and 7 is 14. That's what a lot of people miss. They forget that. And the height is 5.66. And again, now all you have to do is put that in your calculator. 39.62. This one, again, we have our right triangle over here. So we have 3 squared plus h squared is equal to 5 squared. Sorry, I almost jumped ahead. H squared is equal to 25 minus 9 is 16. Take the square root, we get h is equal to 4. And so now the area is base times height. But again, this is where a lot of people miss this. The base, a lot of people just put 8. No, that's this part of the base. This part is 3, so it's 8 plus 3. The base is actually 11. So make sure you're being careful with that. So the area for that one ends up being 44. Now, we already did this where we found the area of irregular figures. For some of these, I just wanted to give you some extra review. But for one like this, it's going to help that it's going to use what we just talked about. So to separate this, I'm going to separate this into a triangle. Now it's a right triangle. That gives us this 7 and this 7. Sorry, I'm not going to use those quite yet. So if you just look at that, we have 3 and 5. So we have a triangle with 3 squared plus h squared, if you want to call that the height, is equal to 5 squared. So it's 9 plus h squared is equal to 25. We just had this math. H squared is equal to 16. So h is equal to 4. So that is 4. That also means that this length is 4. So now we can find the area of this rectangle. We have 7 times 4 is 28. So that's this rectangle. And then the area of this little triangle here is 1/2 3 times 4, which is 6. So the area of the whole thing is 28 plus 6. So the area of the whole thing is 34. So this one, I think this one, oh, this is really similar. So again, I need this height right here. That height is the same as this height, but we don't know either of them. So we have to use 6 squared plus we call it h again, is equal to 10 squared. That's 36 plus h squared is equal to 100. Track 36. Hopefully you guys are getting pretty good at solving problems like this since we started this with Pythagorean theorem where we take the square root at the end. So the h for that one is 8. So the area of the rectangle is 11 times 8. So that area is 88. Area for the triangle is 1/2 base times height. Put that in your calculator. That should be 24. So the total is 88 plus 24, which is 112. Now, these last two problems are just kind of ones to make you think a little bit. They're a little bit different, and they show up occasionally. So the following is a square with the circle inside in such a way that the circle touches every side. So the circle touches here, 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 and here. A lot of different properties you can use with this, or that we'll talk about with this. Find the area of the shaded region. So remember, the area of the shaded region is you're going to take the big area and the small area and subtract them. Well, the big area is the square, but we don't know what the length of the square is. But I know that from the center to the outside right here is 8. So from the center to the outside is 8, which means from the center to this outside, it's the same radius. So that also has to be 8. So for this square, the side length is 16. So the area is the side length squared. That's 16 squared. It's 256. But now we have to find the area of the small shape. Well, we know the radius is 8. So we have pi times radius squared, which is pi times 8 squared. So that's 64 pi. If I were you, since we have one of them in terms of pi and one of them that's not, I would just go ahead and put them all in decimal form. That way you can kind of figure out what the number is a little bit easier. That's 201.06. So now we subtract those from each other. Your answer ends up being 54.94. So again, don't make it harder than it is. You just have to make sure a lot of students get confused with, they don't give you any of the sides of the square. You have to remember, if it goes from halfway to the side, that's the same as this. So the whole length is 16. Now this one's an interesting one because I want you to find this, but then this area that's cut out is a quarter of a circle. So what does that mean for us? Well, if this length is 20, this length is 10, but it's marked with this, so this length has to be 10. Which means from here to over here, what you can't see is 10. Well, that is the radius, and that's the hardest part, trying to figure out or understand what that radius is. Now, honestly, I don't think you'll have one that's this hard on a test or a quiz, but I wanted to go over it and just kind of make you think. So again, we have the area of the big one minus the area of the small one. The big one is going to be this whole square. So that is 20 and 20, or 20 squared. So the area for that one is 400. The area for the small one, the hard part is it is a circle. So the radius is 10, so it's pi times 10 squared. That ends up being 314.16. But that would be the area of this whole circle. I'm not taking out the area of the whole circle. I'm only subtracting out that fourth of it. So once you have that, you actually have to divide this by 4 to get just the area of this part over here that we're cutting out of that. So that ends up being 78.54. And now we can subtract those. 400 minus 78.54 is 321.46. So again, you won't have one that's that difficult, but I like to show you that to kind of get your head thinking, trying to get you think of that kind of mathematical process of figuring that out. If you have any questions, don't hesitate to email me. Have a good day.